So glad you've taken ownership of this project. Like a group. Okay, thank you. So again, we have a horizontal transformation. G of x equals f of x minus 5. Sergio rightly said that the way to write this without having this f of x garbage is to write it as the square root of x minus 5. All he did is he took x minus 5, plugged it in for x. This is a horizontal translation. Horizontal translation. And of course, this is where things get a little bit interesting. Does this move the graph left 5 or right 5?
Right.
Right. If we have horizontal transformations, we do the opposite of what it says. So this is right by 5. This is right by 5. So how do we look? Well, basic square root graph is this. And now I'm starting here and I go, and I'm not going to, and folks, you don't have to build a table every time. At some point, hopefully very quickly, you'll just be able to realize, okay, this is right by 5, let me move it and move on. So how do I do this? Well, I start here, and I think it's always easiest to start when x is 0. We go right by 5. 1, 2, 3, 4, 5. Here's our point. There it is. Fernando, question?
If you put a number before the egg,
The discretions, that's what
Yeah, sure.
are you dividing it or?
Fine. So again, the opposite, yeah. Resistance.
So
And that'll be tomorrow.
when you move it like 5, would it still like? Would it miss like? So they won't hit each other, right?
No, they will not hit each other because this one is, I mean, they will have the, so what's interesting is over here, when I plug in 1, on the original graph I have 1 comma 1, like square root of 1 is 1. Over here, when I plug in 6, 6 minus 5 is 1, so it just kind of comes over here, and this would be 6, 1. So it's just like moved over. So it just kind of reaches those points a little bit later. That's how I think about it. Questions on this? Let me see where we are. Okay. When does class end?
47.
Wow. Okay. It's so amazing how like this. So the first class I taught this in, like I did horribly presentation. I hope these people watch the video. Like this class has gone so much better. Like we did not finish that class until like the bell rang basically. This is really good. Okay. Let me do one more thing though before we get out of here. Before
One more thing.
let you guys practice. The last thing I want to do is the following. Will it get it if it's over here, Lucia? If I write here, will it get the thing?
Yeah.
Okay. So imagine this. Imagine I gave you a table of values. This column is x, this column is f of x. You do not have this printed out, so I'd encourage people to write it down. Okay, here's what we've got. Now, Chepe realized something right away in the last class. He said, "Why is this not in not in order?" That's a good point, and that's what I was going to bring up. If we give you some data like this, might as well just take 3 seconds and rewrite it in order. So let me go ahead and do that. I'm just going to rewrite this from least to greatest. So rewriting it. Still with the table as x comma f of x. So I'm going to start with -1 and 6. I'm going to go 2 and 5, 3 and 8, 4 and 2. So any questions here? Just rewriting so that it is in chronological order. Chronological usually is used for time, so let's say from least to greatest. Now, here's the following question. Given these data points for x comma f of x, find a table for this equation. G of x equals f of x plus 3 minus 2. So they want us to build a table with 4 points for g of x. And they've given us a table for f of x. So the first thing I would do, and I really want to see this on people's papers, I think it is smart to take a couple seconds to do this. Last year I never taught it this way, but I think this is a better way to do it. Over here, you should just write what transformation has happened. So what transformation has occurred right in this area right here? What has occurred right here, Daisy? Left 3. This is very similar to what I did here. So left 3 units. And over here, Chloe, what's going on over here? Down by 2. So we have 2 transformations that have occurred from the original f of x. We went left by 3. Remember, we know this is horizontal. Why? How did we know this was horizontal and this was vertical? How did we know which was horizontal and which was vertical? Kayla? Yeah, so that's definitely one way. Does anybody want to add on to that? That's absolutely right. What else? How do we know like this is horizontal and this is vertical? That was very good, Kayla. Javier, help out. Add more.
X plus 3 is in the x value, and therefore that's the domain, or the x, y, and then the one outside is always the y.
Yep, so absolutely right. Exactly what they both said, right? The plus 3 is inside, the math term is it's inside the argument. The sort of non-math term is that it's inside the parentheses, right? Either way you want to think about it, this is affecting x. The 2 is outside. There's a minus sign, meaning we're going downstairs. So now we want to take these points and rewrite them given these 2 transformations. So let's model how that's going to work. So x, f of x. 4 points. So if you think about this, if I have gone left 3 units, what is going to be the new x-coordinate for the point -1, 6? I went left 3 units. What will be the new coordinate for x equals -1? What is the new coordinate going to be? I'm going left 3 units. Lucia, what do you think?
3.
I'm going left by 3
Oh,
units?
no.
4.
I'm going left by 3 units? 1?
-4.
-4. If I start at -1, I go 1 unit left, that's -2. 1 unit, that's -3. The third unit, -4. So this is going to become -4. 6 goes down by 2. If I'm at 6 on the y and I come down by 2, I'm at 4. Questions? Let's fill out the, oh yeah, Matthew, and if you're good, fill out the rest.
So wait, why did you put -4 for x?
Because here the x was -1, and the transformation said for me to go left by 3 units. So it's like I start -1 on a graph, -2, -3. More questions? If you're good, fill out the rest. Right? It's like 30 seconds to do this. Hopefully we get something like the following. How many folks got this when they did the tape? How many folks got this? Love it. Love it. Good job. All right, so let me stop here. You have 20 minutes left. Yeah, we can cut that off. We have 20 minutes left.
Smile for the camera.
So